to honors calculus. We're moving on to bigger and better things after the quiz. I am not here, unfortunately, but we are going to continue moving on. All right, so today is U substitution. As we know, for derivatives, we have power rule, product rule, quotient rule, and chain rule. For integration, so far, we only have the power rule, so we had to have it in perfect polynomial form in order to integrate. We don't have a product rule or a quotient rule, but we have something similar to the chain rule, which we call U substitution. So that's what we're doing today. Okay? The warm-up is here. I want to see if you can figure this out. Take a couple minutes. Try to figure out if you can figure out what this would be. Okay, so if this is my derivative, think about what the original function would have to be such that if we took the derivative, we get this. Okay, same idea over here. I think this one's a little bit easier. What would the original function have to be in order for the derivative to be that guy right there? Okay, so try this out. If you don't get it, that's okay, because we don't know the rule yet, but technically you can use some logic in order to solve these. All right? So 4.6, integrating with U substitution. So U substitution is pretty much like the chain rule of integration. Anytime we have a function within a function, and we are taking the integral, we need U substitution. Okay? So this was, in terms of derivatives, we should know which one we need the chain rule for. So remember, we have something to a power or something other than x inside a function. So here, this one would require the chain rule. This function is to a power, something other than x, so this requires chain. This one doesn't. It's just x to the third plus 7. This isn't to a power or anything, so this is just normal power rule. This one is chain rule. We have something other than x inside the tan function. And this one is chain rule. This is technically all to the 1/2 power, so that's something other than x to a power. So these are all chain rules. Okay? So you should be good with that. Based on that, same idea over here. Okay, what do you think needs U substitution? So we're looking for something similar to this over here. Do we have something other than x to a power, or inside a different function? Okay, so looking at this one looks like just a normal power rule one, so I don't need U substitution here. But this one, I have something other than x inside ln, so I would need U substitution here. And in this case, U is 3x. U is always the inside function. Same idea here. Okay, this is something other than x inside the square root. So even though we're multiplying here, remember there's no product rule. So we're really looking for anything to do with the chain rule, and the inside function is what the u is going to be. So in this case, u would be x squared plus 2. And the same idea here. Okay, so we have something other than x to a power. So 1 plus 2x would be the u. In order for us to use the U substitution to integrate. Okay, so how the heck do we do that? Okay, so here, this is the one from the warm-up. This is something other than x to a power. Okay, so forget about this. We're going to look for whatever applies the chain rule, which in this case applies to U substitution. So the inner function is x squared plus 5. So that's what I'm going to set U to. From here, I need to get all this in terms of u. So I'm taking my derivative of this with regards to x. Okay, so the derivative of u with regards to x is du dx. And the derivative of this, just doing the power rule, is 2x. I want to get dx in terms of du. So when I have this, I'm going to isolate dx. So I'm technically multiplying by dx and dividing by 2x to give me dx equals du over 2x. Okay, so now that I have my u, I have my dx, I'm going to substitute everything I can into this expression. So I have the integral of 2x, that's still there right now. This is u, okay, so I'm substituting u in for x squared plus 5, and that's squared. And then dx is du over 2x, so I'm substituting that in, all right? I need to get all this in terms of u in order to integrate. So this 2x and this 2x reduce, and I end up with u squared du. And now I'm good to go, okay? Now that I have everything in terms of u, I'm just going to do the normal power rule. So I'm going to add 1, which is 3, and then divide by 3. to do my integration. Now that I've integrated, I can get rid of that du. So this is just my solution right here. And now to finish this off, I know that u originally was x squared plus 5. So I'm going to punch in x squared plus 5 for u to finish this off. And then anytime I do the general integration, I add c. So this is my solution. Okay, so again, this is my position function of that derivative function. So really, this is y equals all that. All right. Hopefully that made sense. I'm going to give you another example. Okay. This definitely would need chain rule if we were doing derivatives. So this needs u substitution. Okay. The inner function is my u. So u is equal to 4x plus 3. I'm going to take the derivative of this, okay, with regards to x. So du dx equals 4, just doing the power rule. And again, I want to isolate dx, so I swap those out, and du over 4 equals dx. So I'm going to rewrite this. Okay, so this becomes the integral of u, substituting, to the third. Dx is du over 4. Okay. Again, I want to make sure, we talked about this the other day, any coefficients I can take out, and if there's any x's in there, I want to reduce it. Okay, so in this case, because it's over 4, I can take out a coefficient of 1/4. All right, so this gives me the integral of u cubed du. And now I can just do the normal power rule. Everything's in terms of u. So I add 1 to give me 4, and then divide by my new exponent, which is 4. 4 times 4 gives me 16, and then I can plug in my 4x plus 3 back in. So this would be my solution, okay? And this would really be y equals, all right? And then I forget however many I did. Okay, so this is an example of cosine. So this is something other than x, okay? So again, I'm not going to go through all the steps. You can kind of read it. But my inner function is 7x plus 5. Taking the derivative, this would be my dx. I'm substituting as much as I can, so I get cosine of u times du over 7. That is a coefficient, so I can take that out. The integral of cosine is sine, so that would be my final answer. Okay. So these are a couple examples that I want you to try, and then again, we also should be able to find the particular solution. So all these should have a plus c. These are all position functions, y equals. But I'm not exactly sure which one it is, because this derivative could start, or the position function really could start anywhere to give me that derivative, okay? But now I want to go through this particular point. So I'm taking my derivative, and I'm integrating that. So this would give me my position function, so y equals the integral of my derivative. This definitely would require chain rule, okay? So my inner function is x squared plus 2. My derivative is 2x, and I'm isolating dx to give me du over 2x equals dx. I'm plugging in as much as I can. So this gives me the integral of 4x. I can't really do anything with that right now. This becomes u squared. Dx is du over 2x. Okay, and now you can see that the 4x and the 2x can reduce to just a 2, and I can take that 2 out. So now I just have u squared du. If I do the power rule, I add 1 and divide. So this gives me u to the third over 3. And 2 times 1/3 gives me 2/3. And I can plug in x squared plus 2 back in for u. So this is my general solution. And now it's basically the same as what we did before. Now that I have my position function generally, I can plug in 0 for x and 6 for y, and then solve for c. So this gives me 16/3 plus c. If I subtract that, which is 5 1/3, I get 2/3. So that's my particular solution. And that's the main idea. Okay, so this one's similar. The u would be 2x. The antiderivative of secant squared is what? What gives me secant squared if it's a derivative? That would give me tan. And then we just kind of go from there. And yeah. Okay, so finish that up. You also have this for homework. These give you the u's, so these ones are pretty straightforward. These 4 don't give you the u's, so you have to figure that out. All right, that's it. Okay, have fun, people. Ta-ta.